Understanding a kernel oops. Understanding a kernel panic and doing the forensics to trace the bug is considered a hacker's job. This is a complex task that requires sound knowledge of both the architecture you are working on and the internals of the Linux kernel. Depending on type of error detected by the kernel, panics in the Linux kernel are classified as hard panics IAA and soft panics oops. This article explains the workings of a Linux kernel oops, helps to create a simple version, and then debug it. It is mainly intended for beginners getting into Linux kernel development, who need to debug the kernel. Knowledge of the Linux kernel and C programming is assumed. An oops is what the kernel throws at us when it finds something faulty, or an exception, in the kernel code. It's somewhat like the segfaults of user space. An oops dumps its message on the console. It contains the processor status and the CPU registers of when the fault occurred. The offending process that triggered this oops gets killed without releasing locks or cleaning up structures. The system may not even resume its normal operations sometimes. This is called an unstable state. Once an oops has occurred, the system cannot be trusted any further. Let's try to generate an oops message with sample code, and try to understand the dump. Setting up the machine to capture a kernel oops. The running kernel should be compiled with config_debug_info, and syslog should be running. To generate and understand an oops message, let's write a sample kernel module, oops. C 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Hashtag include less than Linux kernel. H greater than. Hashtag include less than Linux module. H greater than. Hashtag include less than Linux init. H greater than. Static void create underscore oops. Int 0 equals 0. Closing curly bracket. Static int underscore underscore init my underscore oops underscore init void. Print k oops from the module n. Create underscore oops. Return 0. Closing curly bracket. Static void underscore underscore exit my underscore oops underscore exit void. Print k goodbye world n. Closing curly bracket. Module underscore init my underscore oops underscore init. Module underscore exit my underscore oops underscore exit. The associated makefile for this module is as follows. Objm equals oops. O KDIR equals lib modules $shell uname r build. PWD equals $shell PWD. Sim equals $PWD. All $make C $KDIR subdirs equals $PWD modules. Once executed, the module generates the following oops. Bug. Unable to handle kernel null pointer dereference at null. IP less than FFFFFFFFFAO3E1012 greater than my underscore oops underscore init plus 0 by 12 over 0x21 oops. PGD 7A7190067 put 7B2B3067 PMD0. Oops. 0002, number 1, SMP. Last SYSFS file. SYS devices virtual MISC KVM U event. CPU1. Understanding the OOPS dump. Let's have a closer look at the above dump to understand some of the important bits of information. Bug. Unable to handle kernel null pointer dereference at null. The first line indicates a pointer with a null value. IP. Less than FFFFFFFFAO3E1012 greater than my underscore oops underscore init plus 0 by 12 over 0x21 oops. IP is the instruction pointer. Oops. 0002, number 1, SMP. This is the error code value in hex. Each bit has a significance of its own. Bit 0 equals 0 means no page found, 1 means a protection fault. Bit 1 equals 0 means read, 1 means write. Bit 2 equals 0 means kernel, 1 means user mode. Number 1, this value is the number of times the oops occurred. Multiple oops can be triggered as a cascading effect of the first one. CPU1. This denotes on which CPU the error occurred. PID 2248, COM, insmod tainted, P2.6.33.385. FC13. X8664. The tainted flag points to P here. Each flag has its own meaning. A few other flags, and their meanings, picked up from kernel panic. C. P. Proprietary module has been loaded. F. Module has been forcibly loaded. S. SMP with a CPU not designed for SMP. R. User forced a module unload. M. System experienced a machine check exception. B. System has hit bad underscore page. U. User space defined naughtiness. ACPI table overridden. W. Taint on warning. RIP 0010 less than FFFFFFFFAO3E1012 greater than less than FFFFFFFAO3E1012 greater than my underscore oops underscore init plus 0 by 12 over 0x21 oops. RIP is the CPU register containing the address of the instruction that is getting executed. 0010 comes from the code segment register. My underscore oops underscore init plus 0 by 12 over 0x21 is the less than symbol greater than plus the offset length. RSP 0018 FFFF88007 add 4BF08E flags 00010292. RAX 00000000000018RBX FFFFFFFAO3E1000 RCX 000000000013B7 RDX RSI 46 RDI 246 RBP FFFF 88007 add 4BF08R08 FFFF 88007 AF1CBA0R09 4 R10 R11 FFFF 88007 add 4BD68 R12 R13 16B0030 R14 19DB9 R15 16B0010. This is a dump of the contents of some of the CPU registers. Stack FFFF 88007 add 4BF38 FFFFFFF 8100205 FFFFFFFA0360 FFFFFFFA0360 16B0030 FFFF 88007 add 4BF78 FFFFFFF 8107 AAC9 FFFF 88007 add 4BF78 00007 FFF69 F3E814 000000019DB9 00000002000. The above is the stack trace. Call trace. Less than FFFFFFF 8100205 F greater than 2 underscore 1 underscore init call plus 0 by 59 over 0 x 154. Less than FFFFFFF 8107 AAC9 greater than SYS underscore init underscore module plus OXD1 over 0 x 230. Less than FFFFFFF 81009 BO2 greater than system underscore call underscore fastpath plus 0 by 16 over 0 x 1B. The above is the call trace, the list of functions being called just before the oops occurred. Code. Less than C7 greater than 04250000000000000031 C0 C9 C3000000000000. The code is a hex dump of the section of machine code that was being run at the time the oops occurred. Debugging an oops dump. The first step is to load the offending module into the GDB debugger, as follows. Root at del-rnd-india oops, #gdb oops. Co. New GDB Fedora 7.1-18. FC13. Reading symbols from code oops. Co. Done. GDB add symbol file oops. 0xFFFFFFFA03E1000. Add symbol table from file oops. at text underscore adder equals 0xFFFFFFFA03E1000. Next, add the symbol file to the debugger. The add symbol file command's first argument is oops. And the second argument is the address of the text section of the module. You can obtain this address from SYS module oops sections. Init. Text where oops is the module name. GDB add symbol file oops. 0xFFFFFFFA03E1000. Add symbol table from file oops. at text underscore adder equals 0xFFFFFFFA03E1000. Y or N Y. Reading symbols from code oops. Done. From the RIP instruction line, we can get the name of the offending function and disassemble it. GDB disassemble my underscore oops underscore init. Dump of assembler code for function my underscore oops underscore init. 0x00000000000038 less than plus 0 greater than push %RBP. 0x000000000039 less than plus 1 greater than mob $0 x 0% RDI. 0x000000000040 less than plus 8 greater than XOR %O. 0x000000000042 less than plus 10 greater than mob %RSP, %RBP. 0x0000000000045 less than plus 13 greater than. Call Q0x4a less than my underscore oops underscore init plus 18 greater than. 0x000000000000004a less than plus 18 greater than. Moogle $0 x 0 0x00000000055 less than plus 29 greater than. XOR %O 0x00000000057 less than plus 31 greater than. Leave the queue. 0x00000000058 less than plus 32 greater than. Read. End of assembler dump. Now, to pinpoint the actual line of offending code, we add the starting address and the offset. The offset is available in the same RIP instruction line. In our case, we are adding 0x0000000000000000038 plus 0x012 equals 0x000000000000004a. This points to the movable instruction. GDB list asterisk 0x00000000000000004a. 0x4a is in my underscore oops underscore init code oops. C. 6. 1 hashtag include less than Linux kernel. H greater than. 2 hashtag include less than Linux module. H greater than. 3 hashtag include less than Linux init. H greater than. 4. 5 static void create underscore oops. 6 asterisk int 0 equals 0. 7. This gives the code of the offending function. References. The kernel oops. Org website can be used to pick up a lot of oops messages to debug. The Linux kernel documentation directory has information about oops, kernel documentation, oops tracing, txt. This, and numerous other online resources, were used while creating this article.